Here's our problem. A chemist sets up a synthesis of phosphorus trichloride by mixing 12 grams of phosphorus with 35 grams of chlorine and obtained 42.4 grams of phosphorus trichloride. What is the percent yield? So what we're being asked is, what is the percent yield? So let's put our formula up here. We need the actual over the theoretical yield times 100. The actual yield, remember yield is product, the actual yield is what would be given to us in the problem. The theoretical yield, however, is what we would need to calculate using stoichiometry. Well, if I'm going to use stoichiometry, that means I need a mole-to-mole ratio, and the mole-to-mole ratio comes from where? That's right, it comes from the coefficients of the balanced equation. So now I need to have a balanced equation. So I'm looking at this, and we don't have a balanced equation, so we're going to have to write one. So let's start looking. It was a chemist that sets up a synthesis of phosphorus trichloride. Phosphorus trichloride, do we need to remember our naming? Yes, we do. Do you remember what phosphorus trichloride is? It's PCl3. Now we had our products, our product is phosphorus trichloride, and we have our reactants, phosphorus and chlorine. Is that the balanced reaction? It's not balanced, we know that, but think again. Did we remember that chlorine gas is a diatomic? Do we remember the 7 diatomics? We would need to do that. Now we can attempt to balance it, and of course we see that it's not balanced, and when we put our coefficients in here, we would see now we have a balanced equation. Okay, so let's put the amounts. It's always a good idea to put the amounts given to us in the problem under the reactants and the products so we can see what we're doing. There we go. Now notice that we have 42.4 grams, and that is product, so that's going to be our actual yield. What about the other two? Oh, did you notice we have 2 starting amounts? And whenever we have 2 starting amounts, what kind of problem is that? It's a limiting problem. So now we're going to have to use our methods to determine which is the limiting reactant, because that will give us the proper amount of theoretical yield of the product. So one of our methods is to convert each reactant to product so we can compare them. So let's start with phosphorus. And we know with stoichiometry that we always have to take our starting amount and convert that to moles. So here we go. And then we use the mole-to-mole ratio, which comes from the coefficients of the balanced equation. And then we're going to convert that to grams of product. So this will be our first one, and we see that it's 53.2 grams of phosphorus trichloride. Now we're going to do the same thing again, this time with chlorine. So we take our chlorine, which is our starting amount, and we're going to convert that to moles. So we're going to use molar mass, and molar mass comes from the periodic table, and you know it's the grams in 1 mole. And of course, always be careful that your units are canceling. And then I'm going to do my mole-to-mole ratio, again watching out for units, and then converting that to grams, so we would get 45.19 grams of phosphorus trichloride. So we can see that this one is too much, so that is not possible. This is what we were going to get, 45.19 grams of phosphorus trichloride. That is our theoretical yield. Chlorine is a limiting reactant. That is the one that is used up first. So now we have found our theoretical yield. It is 45.19 grams of phosphorus trichloride. Okay, we're almost there. We're almost able to calculate our percent yield. So here's our formula, and remember, this was our actual yield, and we can put our actual yield in and our theoretical yield, and this is what we get for our percent yield. Whew! Now, in this problem, we had to remember a lot of things. We had to remember naming, we had to remember diatomics, we had to remember how to write a balanced equation, we had to remember about limiting problems and stoichiometry. And finally, we were able to calculate our percent yield. Whew, we're able to do it all. Now, chemistry is a course that builds, so we need to remember the things that we have studied previously in order to continue to solve our problems. Good job, we did it.